Welcome to BSc Statistics students. In this class, I explain criteria of a good index number, which means generally index number reflects the changes in the in a particular variable or relative changes. It reflects the relative changes. It signifies how the relative changes took place in a particular economic variable. Now what we are doing is which particular, like that, to make the appropriate changes, to identify the appropriate changes, relative changes in a particular phenomena, which particular formula is a good formula, which index is a good index. That is our question, for which we have a criteria. In this criteria, the 4 mathematical tests which signifies and which answer this question, and so that which particular index is a good index number, it is going to be identified with these particular 4 mathematical tests. So what are the tests? 1, unit test. What is unit test? Unit test is nothing but whatever the prices and quantity, that is index numbers, price and quantity index numbers we have calculated, those index numbers should be independent of any units of the given data. Now, for example, prices, which will be in the rupees, in terms of rupees, the index number should not reflect the prices, the units of the prices, that is rupees, etc. Similarly, quantities, rice, for example, rice, it is going to be expressed, that is the weightage of the rice is going to be expressed in kilos, units of the price, quantity rice quantity is going to be represented in kilos. Similarly, wheat in kilos. Similarly, oil in liters, etc. So, but whatever the quantity index numbers or price index numbers, the formula which should not reflect these units, then they are independent, which means then they satisfies the unit test. So therefore here almost all formulas satisfies the unit test. They should not reflect the units. They will not reflect the units. But except the simple price index numbers and simple quantity index numbers does not satisfy the unit test. That is, that depends on the given units. Remaining formulas does not reflect that. Hope you understand. That is what the unit test. Second one, time reversal test. Time reversal test. What is meant by time reversal test? That is in the terminology, directly the terminology of the Fisher we observe here. What is the time reversal test? In the terminology of the Fisher said, the test is that the formula for calculating an index number should be such that it will give the same ratio between one point of comparison and the other, no matter which of the two is taken as base, or the index number reckoned forward should be the reciprocal of that reckoned backward, except for a constant of probability, proportionality, right? So this is what the words of the Fisher. If the Fisher said these words, regard, that is for time reversal test. So the time reversal test means the meaning of this, if you interchange two time periods, we should get, that is, we should get one is a reciprocal of the other, which means I express here in the formula, for example, two time periods we have considered for a price index number. The price index number is calculated for two time periods, that is for current time period and based on the base period, that is 0. For example, 0 is the base period and I is the current period. So that is, index number is going to be calculated for current period I based on some particular period is called base period, that is 0. These are the two time periods for a particular index number, price index number. But index number belongs to this particular period. Comparison is with this period, base period. If you interchange these two, that is, if you calculated a new index number as by interchanging 0 as I, that is, and I as 0, we have interchanged the two time periods, 0 as I as 0. Then this index number should be a reciprocal of the original index number P0I. This is what specified by the Fisher. Like that, if you want to calculate, prove this, instead of this, just simply we can prove that P0I into Pi0 is equivalent to be 1. If you prove this, this is enough to prove. If you prove this, this is enough to prove the time reversal test. What are the index numbers which satisfies the time reversal test? Usually simple price index number, geometric mean of price relatives, Fisher index number, Marshall-Edgeworth index number, Walsh, Kelly's fixed price index number, fixed weight index number, which are all index numbers satisfies the time reversal test. I will show you one which satisfies, one which not satisfies. For example, I consider Fisher, I consider simple price index number, very easy index number. I will show you Fisher index number in the another class, right? So I consider simple price index number P0I is equivalent to B. What is the simple price index number formula? Summation Pij divided by summation P0j. I am not considering 100 because I am only verifying, testing the formula. So therefore P0I is this Pi0 I am calculating. That is, we are interchanging the time periods, 0 with I with 0. Here I and 0 here. So therefore P summation P, this is I will be becomes 0 and summation 0 is interchanged with I, Pij. So now we calculate P0I into Pi0 is equivalent to be, this is summation Pij divided by summation P0j multiplied by this one, summation P0j divided by summation Pij. We all will get cancelled and so that is equal to be 1. Therefore, simple price index number P0I is satisfying the time reversal test. Time reversal test, this one. Second one, which is not satisfying. For example, we consider last year, P0I last year. The formula is summation Pij Q0j divided by summation P0j Q0j. This is the last year's index number. You calculate, interchange the periods Pi0 last year. It is equivalent to be, interchange the periods Pi, so therefore P0j, Q0j, therefore Qij, summation P0j, that is Pij, Q0j, Qij. You multiply these two, P0I last year into Pi0 last year is equivalent to be, this is now summation Pij Q0j divided by summation P0j Q0j multiplied by summation P0j Qij divided by summation Pij Qij. Therefore, if you see no term is going cancelling, so therefore it is not equivalent to be 1. Therefore, last year index number, this one, is not satisfies the time reversal test, not satisfies the time reversal test. This is what the way you have to consider, prove the time reversal test, whether any index satisfies the index formula, satisfies the time reversal test. Similarly, now consider next one, that is the third test. What is the third test? Factor reversal test. Factor reversal test. The factor reversal test. We see the statement given by the Fisher. Again, we observe, we study the statement given by the Fisher. This is not the factor reversal test. What is the statement given by the Fisher? Just as our formula should permit the interchange of two items in the previous time reversal test, two time periods, here two items without giving inconsistent results. So it ought to permit interchanging the prices and quantities without giving inconsistent results. That is, two results multiplied together should give the true value ratio except for a constant of proportionality. These are the words given by the Fisher for factor reversal test. So which means if you interchange price and quantities, we should get a true value. That is value index. That is P0i into Q0i is equal to summation Pij Qij divided by summation P0j Q0j. So we test it for Fisher because I write here what is factor reversal test. When do you say an index satisfies the factor reversal test is P0i into Q0i, which must be equal to true value, that is summation Pij Qij divided by summation P0j Q0j. This is what factor reversal test. To prove this, only the Fisher index number satisfy this particular test. Therefore, I am proving the Fisher test. I am considering and proving the Fisher test. You consider Fisher index number, that is P0i. Is it visible? Right. P0i Fisher is equivalent to be under square root of summation Pij Q0j divided by summation P0j Q0j multiplied by summation Pij Qij divided by summation P0j Qij. This is the price index number formula of Fisher. Is it visible? Right. Okay. And quantity index number now Q0i Fisher. Q0i Fisher. It is equivalent to be summation Qij P0j divided by summation Q0j P0j multiplied by summation Qij Pij divided by summation Q0j Pij. This is the formula of the Q0i, quantity index number of Fisher. If you multiply these two, P0i Fisher multiplied by Q0i Fisher is equivalent to be, now if you multiply these two, I am putting one particular square root for this, and so that this is summation Pij Q0j divided by summation P0j Q0j multiplied by summation Pij Qij divided by summation P0j Qij multiplied by second one summation Qij P0j divided by summation Q0j P0j multiplied by summation Qij Pij divided by summation Q0j Pij. Now you see what are the terms are going to be cancelled. Pij Q0j will get cancelled. Qij P0j summation will get cancelled. Remaining values are is equivalent to be this is summation Pij Qij. That is summation Pij Qij whole square summation P naught j Q naught j, summation P naught j Q naught j is equivalent to be summation P naught j Q naught j whole square is equivalent to be summation Pij Qij taking square root outside divided by summation P naught j Q naught j. This is what the value index. So that is, if you P0i Fisher into Q0i Fisher is equal to summation Pij Qij by summation P naught j Q naught j, true value. Therefore, Fisher index satisfies a factor reversal test. Do you understand this? This is what the third test. No other index satisfies Fisher factor reversal test. This test. Therefore, I am coming to I will discuss the fourth one. The fourth one is circular test. Circular test. These are the four important tests. What is the circular test? Circular test is based on shiftability of the base period, which means, you see here, it's an extension of three time periods. Actually, it's an extension of time reversal test. In the time reversal test, we consider two time periods, A and B, or 0 and I. Now here we consider three time periods, A, B, C. For first index number, we consider base period is this. For second one, we consider base period is this. It is going to be shifted. Now, for the next time, index number base period is this. So, based on this particular period, we calculate index number for B here. Based on this particular time period, the index number we calculate for C. Based on this particular time period, we calculate index number for the period A. Now you see here A, B, B, C, C, A. Now the current year in the previous one is considered as base period of this next one. Similarly, the current period of the second one, that is C, it is going to be considered as a base period of the next one. Construct next. This is the first index, this is the second index, this is the third index. Three index numbers we are calculating. That is for example, first one PAB we consider price index number, PBC and PCA. This is called shifting the base period. Here the base period is A, here B, here C. Here the current period is B, that becomes the base period of the next one. Here current period is C, that becomes the base period of the next one. That is called, it is an extension of time reversal test. So therefore, you can simply specify that even though if you interchange the time periods for three time periods, we should get the value is 1. That is PAB into PBC and PCA must be equal to 1. For example, I consider this is what time reversal test. The Kelly fixed weight index number satisfies the time reversal test. What is the Kelly's weighted index number? Which is nothing but P0IK, which is summation Pij Qj divided by summation P naught j Qj. This is the formula. So for which I am considering, I am writing the form values, that is PAB. Based on the base period is A and current period is B. Index number for B is going to be calculated by summation P current period I, that is B, Bj Qj divided by summation base period 0 A, Paj Qj. Similarly, now you interchange PBC. B as a base period, C is the next period, the another period. If you consider PBC, that is summation P, B is the current, B is the base period. If you consider his, this is better one to consider. If I is the current period is C, PCJ Qj divided by summation B is the base period, that is base period is 0 here. It is B, so PBJ Qj. Similarly, I am writing PCA Kelly is equivalent to B. This is also Kelly, this is also Kelly, right? And summation, this is P, C is the base period, A is the current period. This is the current period A. PAJ QJ divided by base period summation C PCJ QJ. Am I right? Now it is required to calculate PAB into PBC into PCA. If you consider it for Kelly, this is of Kelly, all three is equivalent to B. Now you write summation PBJ QJ divided by summation PAJ QJ multiplied by second one summation PCJ QJ divided by summation PBJ QJ is equivalent multiplied by summation one more PCA, that is summation PAJ QJ divided by summation PCJ QJ. Now you see PBJ QJ, PAJ QJ, CJ QJ is equivalent to be 1. Therefore, PAB into PBC into PCA is equal to be 1 for Kelly's index number. Therefore, this satisfies Kelly's weighted index number satisfies circular test. One more is also going to satisfy, that is simple average of price derivatives based on geometric mean is also satisfies this particular test, circular test. No other index number is going to be satisfied. Even Fisher index number also not satisfies that fact, that is circular test. So based on all these are called mathematical tests. If any index satisfies maximum number of tests, which is called a good index number or an ideal index number. Of course, we know the Fisher index number satisfies unit test, time reversal test and factor reversal test. Therefore, it is called the best index number or ideal index number that we discuss in one more class. So these are called mathematical tests. For criteria of a good index number, we discuss these 4 mathematical tests to know which index number is a good index number. So therefore, this is the criteria of good index number. The 4 mathematical tests are being discussed here. Thank you very much.